So once you open the Jupyter notebook, you are going to see something like this. This is the first. This is your root directory, like your memory card you have in your SIM, where you have different folders: the music folder, the video folders, the photos, and all other things. To make it easy and for beginners, the best thing to do is to go to your desktop. This is. Can you see the desktop environment? I think I need to share the whole of my screen. I'm coming. Okay, you see the interface like this. This is the root directory of your system. I'm using Windows. In Windows, this is what you see. So to make it easy, the first thing you should do, go to your desktop. This is the desktop environment. Then create a folder for this class. You can name the class whatever you like. So I'll be creating. So create a new folder. Just right click on the system and click on new. You see something like a new folder coming up. My system is slowing down. I just turn it on. This is the desktop. Just right click, then new. From new here, you create a new folder for the class, new folder. So I will name the folder Python class. This is the name of the folder. So I will now go back to my Anaconda, to my Jupyter Notebook directory. This is the directory. I have the folder saved on my system. So I will go on my desktop. So I will go to desktop from here. Then I will look for the folder, the Python class folder. So this is my desktop folder. Now I will go to P. This is the folder Python class. We can see the folder is empty because we don't have anything in it yet. So to create a new file, you come here, you can see this new button. You click on new, then you create Python 3 because that's what it comes with, an account that is pre-installed in the Jupyter Notebook. Once I click Python 3, it will open a new Python file for me. And a good alternative to Jupyter Notebook is the Google Colab. The difference between Jupyter Notebook and the major difference is that this Jupyter Notebook is offline, but the Google Colab works online. And to get that, just go to colab.research. Colab.research. Just go straight. Once you type this colab.research.google.com, what was my network? What's wrong? I'm still connected. Okay, that's one of the disadvantages of using the Colab. So we'll be sticking. We stay with our. We stick with our Jupyter Notebook. This is the Jupyter Notebook interface. So let me go to my folder where I have the lecture material for this class. This is the folder for the class, the one I created for the class.
So it's this is spelling.
What did you say? Oh.
The spelling here. Yeah.
Thank you. For those that will be making use of Google Colab, where you go to colab.research.com.google.com, this is the first thing, the landing page you are going to see. Just come here. This is the landing page you are going to see. You will see your most recent file, the last notebooks you work on. There are a lot of things you can do here. There are some example notebooks you can work on. There are recent ones that will show you your recent activities. Then you can import you can import from Google Drive, the notebooks you have on your Google Drive. Then you can import from your GitHub repository as well. And you can upload a local file. Maybe you have something on your laptop already you are working on locally on your Jupyter notebook. You can upload it to Colab. But for this one now, it's good like starting out fresh. You just click on create new notebook. It will take you to this interface. The interface looks like this. This is the Jupyter notebook interface. This is the Colab interface. The two of them look alike. This is the interface. We have the title bar. This is the title bar. We have the one up here is the title bar where we have the title of the file. We have this Jupyter logo, and we have the menu bar. We have the file menu. We have different options. We have the edit menu. We have different options. We have view menu, insert menu, the cell, the kernel, the widgets, and the help menu. And to start with, we start by naming this file. Let me call the file. You just click to name the file, just click on the untitled. By default, it will be untitled. Just name it. Okay, Python day1. Python day1. Just press enter. That's the name. The extension for this Jupyter notebook is .ipynb. We know for text file, the extension for it is .txt. That means it's a txt file. And we have .py for Python file. We have .js for JavaScript, .html for HTML files. But for the IPython notebook, it's for .ipny, which means IPython notebook. This is how the interface look like. So this is the lecture material I've prepared for the class. And we have the outline here. It's for data science and analytics. I wrote this with Jupyter notebook. We have the course curriculum, the timetable. It's going to be on weekend. Saturday and Sunday. Let me quickly show you the this is the attendance list for each and everyone that registered through the link. And here is the registration number for each one of us. This is what we'll be using to submit our assignment instead of our name or our email address. And this is the number of people that registered. We have 46% male, 53, almost half, like 50-50. For the work status, we have majority of the people are students. We have like over 60% students, which are either undergraduate or graduate students. And we have people in the working class too. So there are a lot of people. And for the reason why we chose this Saturday and Sunday, we selected it from the data people field. For the first day, majority of the people choose Sunday for the first day, followed by Saturday. For the second day, they choose Saturday, followed by Sunday. So from the 2 days, from the data we got, the best day to fix that majority of the people choose is Saturday and Sunday for the 2 classes. And for the timing, for day 1, majority of the people, they choose 5 to 6, which is not, for myself, it's not convenient for me. For the second day too, they choose 5 to 6. But the next one after the 5 to 6 is 9 to 10, which is this yellow bar. For the day 2, the same thing, we have 9 to 10. That's why I've decided to go with the 9 to, this is why I decided to go with the 9 to 10. So this is the outline of the course. We'll be talking about introduction to data science. What is data science? Then the application of data science. Then data science tools, the different materials we use for data science. Then after that, we go to Python fundamentals. The installation, I believe all of us have gone through the installation process. We have our Jupyter notebook working. Majority of the libraries and packages we'll be needing for the course, most of them are pre-installed in Jupyter notebook. We just need to install maybe a few of them, like the cat boost. Yeah, I think the cat boost and some other ones we might need. Then the syntax, this is how we write code in Python. Then variable, how to write variable. Then comment. You have the different data types we have in Python. The string, the boolean, the operators, then the list, tuple, dictionary, conditional statement, then how to write a function in Python. All these, they are Python fundamentals. Then after that, you can now go to Python for data analysis. That's where these NumPy, pandas, and others, that's where they come in. And we use panda. NumPy simply means numeric Python. We use it for mathematical computation. and we have pandas. Pandas majorly basically is for data frame manipulation, and we use it to read file and write to file as well. And we have a library for time series analysis in data. And we have merge, join, concatenate, group by. Those ones are for data frame manipulation. And we have SciPy. SciPy it means scientific Python. We use it for mathematical computation like the sine, the pi, square root, and some other things. We have visualization libraries in Python as well. When we talk about visualization, it simply means graphical representation of our data, like the bar charts, all these things. All this bar chart, this is pie chart. Do not chart here. This circular one, they are do not chart, and this one they are stacked bar charts. So we have libraries in Python that we can actually use to plot those things. And the first one, there is a basic plot for pandas for Python. They called it. We can plot data frame directly. Then after that, there is matplotlib.pyplots is for visualization. And after that, we have Seaborn. Seaborn is built upon matplotlib. It's a bit advanced, and it makes our plots more beautiful. And there are a lot of things we can plot: pie chart, bar charts, line charts, scatter plots, and how to customize our label. We want to make, okay, this is how we want this to be our title. We want this to be our label, the X label, the Y label. Then we have how to clean data, how to process data. And there is a column, there is a section for EDA as well. EDA simply means exploratory data analysis. This material was actually prepared for a group of students initially, but they didn't like, they were not so serious with the class, so we decided to just stop the class. This is part of where we plan to discuss about machine learning, but I don't think we include this in our own class because we don't plan to include machine learning because of the time frame. That's just 8 weeks. Then we talk about career opportunities, look up people, like spread what you, anything you do. And we have some project ideas. Are you still following, please? Hello?
Yes, yes.
Yes, we are.
I hope I'm not too
Yeah.
fast.
Taking it.
I hope
No,
I'm not
you're
too
not.
fast.
None at all. None at all.
Okay, we have some project idea. The project idea, they are just simple stuff like a menu for a restaurant. This is just like a Python. Okay, you create a list, then you check for the, if there's a particular food on the list, you order. If not, you tell the person that, oh, we don't have this, please try another thing. Then this gets the number. You will ask user to input a number. Then the program will be guessing the number. If the number is lower, the program will, oh, sorry, the number you type is greater than the actual number. Then we type a lesser number, a smaller number, until the correct number is guessed. That's like a game. Then we have a weight converter. This one is just, okay, maybe you input you give this program your height or some, you give the program your weight, let's say in meter, then it will be converted to kilo in gram, then it will be converted to kilogram. Or you give the program, the system, the program, you give it your weight in kilogram, you ask it to convert it to gram. And we have the BMI calculator. I think the BMI means body mass index or something. So you give the system your height and your weight. Then it should tell you, okay, this is your BMI. Your BMI is normal. Your BMI is high. You need to see a doctor, or you need to stop eating this kind of food. Then we will work on a supermarket data. I think we included this students machine learning parts. We'll have worked on machine learning projects, which is predicting cancer or something. So I saw some questions in the, when people are registering for the program. I saw some questions. This was one of the questions. Will we eventually get internship opportunity? The class is just to introduce students to like the basics of data science. I'm not promising any internship opportunity, but if you learn from this class and you try to put more effort to work on some other things on your own, with time you can always get an internship opportunities, and you can get other, like there are other sources of, there are many opportunities you can get apart from internship. You can be working with people, doing assignments for the people, doing projects for people. And some people say, are the selected day flexible or fixed? The selected day were flexible before, but we tend to fix them now based on what we have here. So that's why we choose Saturday and Sunday, and the time to 9 to 10. And is this program under a university or personal? The program is not under any university, it's my personal program, the one that think I should do it for people. I don't know if you have any question for now, but I will stop sharing my screen.
Hello?
Hello, I can hear you.
Hello?
Hello, I can hear you.
Please, I'll be grateful if you can include machine learning.
It's
Thank you.
it's actually because of the time frame. You know, the plan for the class is just 8 weeks. Who else is interested? Who else is interested in machine learning?
Yes, I'm interested as well.
I am interested.
Okay. You can maybe after the end of this, but it's
I'm
good
also
to
interested
understand.
in the machine
It's good
learning.
to understand the
Think we
basics
all
of
are.
data science before diving into machine learning. You know that okay, if I see this type of data, this is how I'm supposed to treat it. If I see this type of data, this is assumptions I'm supposed to make on it. You get that? You get that?
Yes, sir.
Please teach. Okay.
Any other questions? Do you have any other question?
No question for now.
Can we go a bit further, or we should just end the class for now? What do you think?
We still have 5 minutes, sir.
Or we are tired?
We still have 5 minutes.
To 10, right?
Yes.
Okay. Let me try and share my screen again. Okay. I studied microbiology actually. So during my final year, that's when I developed interest in tech. So I finished from OAU. So I started with AI plus OAU. It is a data science community organized by, it's majorly from Data Science Nigeria. I know majority of us will have known about it. So currently I work as a data science mentor for Ustaki. And I also review students' code in the data science category. Though the data science mentor is a full-time, like it's remote, but anytime a student is facing one or two challenges in the course of learning, we attend to such students privately, we solve the problem together. For the code review is a kind of contract-based, students are submitting their projects every now and then anytime you feel like, oh, you are free today, you just check around, you review as many as you can review. There are prices for each of the codes. Let me show you the dashboard. Can you see the screen? Hello?
No, sir.
Yes, we can.
Can you see the screen?
It's not showing well.
You
Really?
can only see the one that contains our mail and the visualized data.
What about now? Can you see it now?
It's the same thing. No?
I will share an attendance sheet with every one of us. Just look for your You will look through the attendance, you will look for your registration number and click either you are present or absent. But let me know when you can see the screen. I'm trying to share again now. Can we end this class by 10:30? It won't be like that next time. Can we?
Okay.
Yes.
Okay. My screen is showing sharing from here. I don't know why you can't see it. Everyone cannot see it.
Can you hear me? Hello, can you hear me?
I can hear you.
From my end, it's showing a small icon for window for Windows displaying your things. I don't know if it's same with others.
I
No,
think that's the
no.
general
Yes, that's exactly what I'm
interface.
saying as
I'm on
well.
another page now.
I'm seeing RA, PA,
S.
and some stuff. Yeah.
No, it shouldn't be.
Yes,
I,
that's
I
what I'm
think
saying.
I think you're just sharing only a window. Maybe you should share the whole of your screen.
I share the whole of the screen, the entire screen.
I mean, you should
And it's
maybe you
playing
should
very
stop sharing. Maybe you should first stop sharing this particular window and then share your screen later on.
Okay. Let's just leave the coin join again.
She refresh to come back to normal.
Yeah, exactly. It's better now.
No. Hello, can you hear me?
Yes, sir.
Yes,
Okay.
I can hear you.
Can you see the screen now?
Not
Yes.
yet, sir.
Yes, sir.
Okay, this is how the Ustaki platform looks like. This is where we review students' codes. Ustaki is an education tech company. They do like different kind of programming course, front end, back end, data science, and all sort of things. This is the code I just accepted to review, but I've not done the revision yet. This way we receive the, okay, I have a code. This one now, if after reviewing this one, I can just come here, accept another one. Then I have this one here. And these are the one I've reviewed so far. And these two things, they are separate, like the reviewing code and the mentorship, they are just different. They are different things. This is the mentorship dashboard. This is the mentorship dashboard. These are the issues with the student. Okay, I have issue installing so software on my system. Then we send a call link to such a student's half meeting, try to solve it with him. These green ones, they are the ones that have been resolved already. The red one, sometimes you message a student, you will not see a response. There are some of them, like for years, you won't see anything from them. You just keep it with, okay, maybe the student will still come back anytime, like this one. So you message to them, you don't see any response. So those are the kind of things I do. So the program for day one is introduction to data science. I've told you about myself. Then you talk about data science. Data science is just like data. We all know data is just raw information. So data science, anything that has to do with data. And we know in today's world, almost everything is data is involved. So it's combine multiple fields: statistics, scientific method, artificial intelligence, and data analysis to extract values from data. So it encompasses a lot of things: preparing the data, cleaning data, manipulating data, and deriving insights from the data. According to one of the, should I say, one of the scientists or someone said, is a data scientist, a statistician who lives in San Francisco, just like data science is a packaged statistician, like it's just about packaging. And another person said a data scientist is someone who is better at statistics than any software engineer and better at software engineering than any statistician. Like data scientist is someone in between the two. So we have the hierarchy of data science, the different people involved in getting data ready, and from the beginning till the end of data science. We have software developers. Those are the people that collect data, they deal with the database. Then we have data engineering. Data engineering, they make sure that you input data in the correct format. Then they extract data. For example, we just get data for analysis. Those data that we analyze, the process that it's passed through before getting to us, that's the work of data engineering, then software developer. Data scientists, they are the one that, okay, we get this data, they analyze, they derive insights from the data. Then we have people that put it into use. They call them machine learning engineer, research scientists. They put it into production. For example, a data scientist can build a model. The model stays on the computer like this, on the notebook, on the Python file or whatever it is. But it is the ML engineer. This and we call them ML ops, like machine learning ops. So they are the one that put the code, the model into use. For example, you build a model to predict if a transaction is going to be fraudulent or not. The function of the data scientist is to build the model and see that, oh, the accuracy or the precision of the model is fine. But it's the work of the machine learning engineer to put it into production, whereby they will use it to monitor real life transaction and they give feedback. Okay, the model is performing well, the model is not really doing well. So that's the function, the hierarchy of the classification here. And we have, most time I've seen a lot of, like, what is the difference between machine learning, data science, data analyst. So there are a lot of professions in data that is related to data. You have data analyst, data scientist, data engineer. What else? There are a lot of them. The most common one, like the most controversial one, is the data analyst and data scientist. To me, the major difference I see between the two is coding. You can be a data analyst without knowing any programming language, any Python, any app, anything. You can be a data analyst without that. If you know Excel very well, I know a lot of people that are making money. Their own work is to analyze data through Excel, and they are doing very fine. That's data analyst. We have people that use Tableau and Power BI. Those ones, we call them data analysts. We call them business intelligence analysts, BI analysts. So those people, they don't really know to know about coding. It's mostly drag and drop. You just drag and drop and you create features that you need. But if you say you want to be a data scientist, you must know about coding. To me, that's the major difference between data analyst and data scientist. For data engineering, they deal majorly with cloud. Most of this data, this day we are generating data daily and it is getting bigger day by day. So they are the one that manage data. They make sure our data is secured in the cloud. They make sure they have, like, the right people have permission to the data. For example, you have organization data in the cloud. You don't want people outside the organization to have access to the data. So that's work of the data engineer, then data engineering, and we call them cloud engineers. Where they manage the cloud where we store our data, and they are the one that make sure we retrieve the exact data we need, the amount of data we need at the right time. That's the work of data engineer. They are the one that also restrict, for example, when they are generating data, you ask someone for his age, and the person is putting 32 in words, THIRTYTWO2. They are the one that make sure that such entries will not be allowed into the data. So they are going to try to manage data. That's work of the data engineer. We have ML engineer. ML engineer, they are firstly, for someone to be a machine learning engineer, you must first of all be a data scientist. Like transition is a kind of transition from data scientist into ML engineer. After you've been building the model, the next thing is to put it into production. The act of putting it into production is ML ops. That's the function, the work of the machine learning engineer. That we call them machine learning engineer, and some other ones that I cannot remember right now. So the pipeline for data science project or anything that's related to that, the first thing is to collect the data. Then after getting the data, we call this data acquisition to get the data. After that, we pre-process the data. Data pre-processing simply means cleaning the data. For example, you have a lot of things. Maybe you have gender. For gender, for example, you have F in a column for female, you have M for male. In some other entries, we have MALE for male, FEMLE for female. You have different options for male, different options for female. You need to clean such a data to put everything together. Okay, anything that is male, we want it to be M. Everything that is female, we want it to be F. And some other things like that. That's part of the data cleaning process. Then we have exploratory data analysis. That's EDA. EDA is just, okay, checking through the data. How many rows do I have? How many columns are there in these data sets? What is the relationship? What is the relationship between this particular column and the other? For example, you see, okay, this is a data about student performance. Let's say 300 level student of a so school. Then you see their, let's say their CGPA. Then you want to see the relationship. Okay, what is the relationship between the gender of a student and their GPA? You find out that when you plot a graph, you find out that female students, they have higher GP than male students. That's EDA, exploratory data analysis. You are trying to find some relationships, some insights from the data, majorly through visualization. That's exploratory data analysis. And we have different tools used for data analysis. We have, when we talk about languages, we have many programming languages. We have Python, we have R, we have SQL, we have JavaScript, we have Java, we have MATLAB, C and C++, and a lot others. So majorly the most used programming languages for data science is Python and R. And there are a lot of questions on which one is better, Python or R. Actually, for me, the two of them are good. It depends on, like, from where you are looking at it. For if you are going to be using it, Python is a simple programming language, and it can be incorporated into a lot of things. That's why majority of people will go for Python. And it can be used for modeling. Okay, you want to build a model, you want to use it for some other thing. Why R majorly is very, very good for statistical analysis. You want to test a lot of hypotheses. You can do that in Python too. But Python is an open source project. A lot of people are contributing into it day by day. So something that are not in it, people are trying to bring it in. R is very good for data statistical analysis. And we have the SQL. It simply means structured query language. Yeah, it's kind of majorly what I've used SQL for is for database management and administration. You use SQL to create a database. For example, let's say a particular school. Okay, we have a database for the school. Inside that database, we have different tables that are linked to it together. For example, we have a table of data about students where we have their name, their student ID, their phone number. Then we have another table inside the same database of the same school about the parents. Each parent is linked to the student ID. Okay, this ID, this is his parent, and then we have the department database, we have the parent database, we have the staff database. So that's the function of SQL. You create database. Then when we need data to analyze, maybe let's say the school team wants to analyze each department data, then the SQL can be used to get such data. Okay, you send a query. I need a data from so table containing so maybe the number of students is, let's say, 1 to 1,000. We just need the data about 100 students. Then we know we have different tables. We have the student table, the parent table, the department table, and the staff table. Okay, what we need is the student in our data we need, we want the student ID to be there. We want to know the parent of each of the students. Then we want to know the department such a student belongs to. So for that, it's like we are combining a lot of like 3 or more tables to retrieve the data. So that data can now be taken into Python or R for analysis. That's the function of SQL. The SQL too, not anyone cannot just go into the database to retrieve data. There are some restrictions. Maybe people working with the IT of the school, they are the one that have password, and they are the one that give access to the data, and they are the one that give access to the data. Okay, these people need this, we need to give them. And we have different libraries in Python for data analysis. I've talked about the NumPy, the Pandas, Scipy, Scikit-learn, Matplotlib, Seaborn, PyTorch, TensorFlow. This one, they are for deep learning. Deep learning is an advanced form of machine learning. Yeah. And we have GitHub, Stack Overflow. When I was talking about the differences between data scientists and data analysts, I mentioned Excel, Tableau, and Power BI. If someone knows any one of the 3, let's say Excel, very well, such a person is a data analyst. Tableau, the same thing with Power BI. We use Tableau and Power BI for dashboard. Okay, the major advantage they have over Excel is we can use them to analyze a very large data without causing any harm to our system. We can use them to analyze large data. They are used for live visualization, like interactive plot. For example, let me check one of the ones I have here. Tableau. Power BI. When we talk about an interactive dashboard, it means the dashboard is changing with when you are trying to, like when you are clicking different things on the dashboard, you have something changing on the dashboard. For example, this is one of the dashboard I prepared. Let's check Power BI too. Can we still see the screen?
Yes. Yes.
Okay. This is the global CO2 data, CO2 carbon emission throughout the world. So we have the range here. This is the average per average CO2 per capita. It means per country. We have the green one, like almost close to 0. I have the very red one, which is the maximum. Maximum of them is 62. If I click on a particular country now, you can see this place is very, very red. Let me click on it. Why do I have this zoom button? I don't know what's wrong. Okay, we can see here, this is South Sudan. It has, let's say, the least metric of CO2 throughout the world. And we have some country that is, I don't know, this thing is not coming up well. What's wrong? Okay. Okay, let me just go with this. We can see this, right? The first one here is W, where the one here is Power BI. This one is just about, I think, United States revenue or something. This is the general dashboard. Then when we focus on a particular state, everything you are seeing on the screen is representing the whole data. Then we want to focus on a particular state. You will see that everything on the board here, each one of them will be changing. Let me start with the California. I click on the California now. You can see every other thing is changed. we have the average of difference here showing only California. Then we have the map highlighting only California. Then we have the sales over projection. It is about, okay, this is we project, let's say California next year, we project so amount for California, like revenue. Then in the actual sense, when it gets to that year, it's either we get exactly that same amount below it or above it. So that's what the visualization is about. We can see this is everything we are seeing is all about California. You can see percentage over projection. It increases. It's increased 161% over the projection. It's like very, very good. Then we have the Washington. We can see it here. Everything is changing on the dashboard. Then we have the red ones here. This is Alabama and Arizona. You can see this is like 148% lesser than the projection. Then we can see, this is not for Alabama, this is for Alabama. Okay. This for Alabama is the least, 51%. And we can see the map, the average of difference here, and we can see the area on the graph. This is the graph of the United States. That's what it meant by something being interactive. And for interactive plot, we can use either this is the Power BI dashboard, or we use the Tableau. This is Tableau. I don't know why this one is not coming up. Wait, let me check another one. Let me check this. You can see this, right?
Yes.
We can look for
Yes,
the
we
country.
can.
What is this? Okay. I think there is a dashboard. Let's see, O2. Don't worry, let's leave that for now. We understand what I mean by when there's a plot, a dashboard, like a graph is interactive. We understand what that means by now. Like everything changing according to what you select on the graph. That's the meaning of an interactive plot. Then we can use Tableau and Power BI. The two of them, they are very close. They are like competitors. But one major difference is to use Power BI, you need to subscribe. Like it requires, for you to be able to explore most of the features there, you need a kind of premium subscription. There are free, there are things you can do with free subscription too, but it won't be as the premium one. For the Tableau is free, and you can always share your dashboard with anybody. So why we choose Python for the program, because Python is it's a popular high-level programming. We have high-level programming language and we have machine language. When we talk about high-level programming, it means the language is very close to human language. Like the way we write, the way we speak is very close. Normally, we know our computer, all it understands is just, let's say, 1 and 0, no numbers. But Python tries to bring programming closer to human by making it easier. Like, for example, like JavaScript, if you want to print hello, I did JavaScript in my, let's say, maybe part 2 or part 3. If you want to do something in Java, you want to print hello world, you are going to write like, I think 12 lines of code. But JavaScript just print hello world, you are done. That's the meaning of high-level programming language. Like it's very advanced. So we use it for data science, automation, web development, and artificial intelligence. And the general purpose support a lot of things. That's why we choose Python for the class. And it's not according to these people, it's known to be the best programming language for data science, and it is used by big tech companies for their data science tasks. And one of the reasons, the syntax is very simple. Like I've said, just print hello, and hello will be printed on the screen. Then we have applications of data science. Data science is being applied in different industries these days. In the health, doctor makes use of it for past data in making decision, diagnosis, treatment of diseases, educational sectors. You can predict students dropping out of school. Yeah. And we have NLP. In health, we use this for medical image analysis. For example, you have a scanned image of, let's say, a particular disease. Then you try to predict, okay, what's the outcome of this disease? Then we use it for drug discoveries. They use it in genomics as well. For finance, we use it for fraud detection and loan defaults. Fraud detection is okay. You have a set of data, a set of transactions going on in, let's say, bank or mobile app. We always, like most, sometimes we have fraudulent transactions. So we detect based on the way the transaction was carried out, you dictate that, oh, this transaction is likely going to be fraudulent. For example, you find out that it's a debit alert, it's a debit transaction, it was carried out, let's say, during, let's say, midnight. Yeah. And the amount is not usual. Maybe the owner of the account used to, for debit, the maximum debit the person have ever done is, let's say, 10,000. Then you find out that 100,000, the amount for the, so you train the model to predict that this kind of transaction is likely going to be fraudulent. And we have loan default. Loan default is to know, okay, you are, for example, there are a lot of companies that they loan people money, they borrow people money for a period of time, then they ask them to pay back. Loan default is to check which of this person is going to pay back, which of them is not going to pay back. The people that doesn't pay, that do not pay back, people that do not pay back, they are the ones that default the loan. So based on, if for a future, for example, maybe you are getting a customer, then you have their data. Based on past customer you've had, you check that, oh, with this data, it's correlates with some of our people that default, that did not pay back. So we are not going to give this person the loan. So we use modeling for that. Then we have education to predict if a student is going to drop out or not. Then we have the natural language processing. There are many various applications of the natural language processing. We have the chatbots. We have this one on most websites today. When you log into the website, you see something by the corner of the screen. Oh, do you need someone to chat with? Then you start chatting with the person. There are a lot of WhatsApp bots these days too. Like there are a lot of banks, schools, and we have VA. VA is virtual assistants. We have a lot of them. We have Siri, we have Alexa. Oh, please do this thing for me. Please play this song for me. And we have speech recognition. We have translation. Translation is just typing something into Google. We have Google Translate. It's a very good example. You type something in English, it translates it to French and a lot of things like that. That's natural language processing. And we have autonomous vehicle. This is an application of machine learning, but it's a reinforcement learning. Autonomous vehicle is just self-driving car. You train the model with a lot of image of people, road sign, a lot of things. Then you tell the model, this is a human being. If you hit this person, you penalize the model. Next time the model sees such a thing, it won't go near it because you know that's a penalty. But when the model does something good, maybe the model run away from a child or from a tree, you reward it. They kind of reward and what's the other form? Reward and what's, I forgot. So that's autonomous driving. It's reinforcement learning. Reinforcement learning simply means learning by doing. Yeah, learning by experience. You do this, it's not good, you don't do it next time. You do this, is good, you do more of it next time. That's autonomous vehicle, and that's the things behind it is my reinforcement learning. You reinforce while learning. Then we have data science, machine learning, and deep learning. Data science, just anything that deal with data. For machine learning, we need to make use of data. Machine learning simply means the machine is going to learn from the data. Then we have deep learning. Deep learning is an advanced form of machine learning. So, and we have this Python for data science. This is where we are going to start anytime we decide to start. I think we can stop here. If you have one or two things to ask, it's a good time to ask.
I have a question. First off, thank you for the introduction. I think I'm beginning to understand what this is about. My question goes, do we need to have a mathematical background to be able to understand this better?
This is a very good question. This is one of the things that scared me when I started. Actually, there are some of the concepts. If you are good at the mathematics, it will be a kind of advantage, especially when we talk about machine learning. There is nothing in machine learning other than mathematics, just algebra, calculus, nothing more than that. But if you don't still understand, but it's require mathematics, just basic mathematics. But you have a deep knowledge of mathematics, it will actually be a great advantage to you, because most of those things, all these we have different models. We have linear regression, logistic regression, gradient boosting. All of them, they are mathematical computation. They are mathematics. But if you don't know it, it's fine. You just go with what is apparent. All these models, they are mathematics that people compute together. They give us the finished product. That's what will be applied. But if you know the mathematical computation behind it, you can even build your own model. You can build your own linear regression on your own without importing it. But to make things easier, there are people that have computed that for just imports. Like, for example, you don't know how to prepare food, then some people have a prepared food already. Just go to the kitchen, pick whatever you need. The only difference is that, okay, you don't like this food, you have to eat it like that. So, except you see something else that is prepared and you like it, else you need to prepare your own. If you can't prepare your own, you just go with what is available. And it makes one understand the model. Maybe the model is not performing as expected, where you are tuning the model to do better. If you know the mathematics behind it, you can decide to change some of the things there. But it is actually not not knowing mathematics. It shouldn't be a barrier, but a great advantage if one has the knowledge. Me myself, I'm not that good at mathematics. It scares me. Did I answer the question?
Okay, thank you. Yes, you did. Thank you so much. I think I
Okay.
might have another one, but I don't know if you're there yet.
I'm still with you.
Okay. I feel like I don't have the words. Okay, for example, you know how we try to create websites and then we save in HTML and we can actually view our work or the process. How do we do that with Python? I mean, if you were to save your work in a folder, how do you get to view the process of your work?
I don't know if I get to what you said, but
Okay.
let me try to explain. Like, for example, you are trying to build a website, an HTML website, then you right click on your browser and you run the code and you see the website live. Is that what you're talking about?
Yeah. For example, like I
Oh,
was creating HTML and then I save it like in HTML format,
okay.
and then
Let me give you an example here.
yes.
Maybe this is what you're
Okay.
talking about. Print hello. You want to see the hello printed, right?
Yes, please.
I've opened this down. There are in the next class we are going to talk about the Jupyter. We've not really discussed. We talk about Jupyter interface, how you make use of each of them, and there are some shortcuts to make your work easy, like to be more productive. You can see the yellow on the screen.
Yes, I
So
can.
that's it. Two
Yes, I
plus
can.
two. 2 plus
Okay.
2.
4.
You can see 4 on the screen.
Yes, I
Yeah.
can.
One of the
Okay.
advantages of
Input and
all
output.
this one I've done now, they are just marked down. There are a lot. I've seen many books that they were written in Jupyter Notebook like this, not not Microsoft Word. They just type everything like this in Jupyter Notebook. You see this one. This looks like a book, right?
Yes, it
Yeah,
does.
it's fine. But basically, it's just for code. You cannot change it to Markdown if you want to be in a text format.
Okay.
So we can start with that in the next class.
Okay.
Any other
Thank you so
question,
much.
please? You're welcome.
Thank you very
Any other
much, sir.
question?
No question really, but I think, are we going to go through the outlines one by one?
The
The
what?
outline as you listed it in the screen now.
Okay, I should go over it again. Okay.
Are we going to go through it in the next class? Going through it line by line.
Yes, we start with the base. Let me check for you. You can see the outline here. So we start with we are done about I've talked about application and the tools we use for data science. That's what we discussed tonight.
Yes.
So in the next class, we will start with the Jupyter Notebook, the interface, how to use it. Then we can start creating a view variables. Then we can talk about data type if time permits us.
All right,
So
sir.
after we'll be taking this one after the other till we finish. After when we cover all of this, that means we are done with Python fundamentals. Then anyone doing this is kind of advanced. Let me say intermediate, because pandas, when you start reading a data frame, that's when you are really working on data science.
All right, sir.
Any other question? Any other question, please?
No. I think you've made justice to the time.
So
We
I
started
want
around
to
9:30.
I want to send you an attendance sheet right now. I will send it to the link. You just go to the Excel sheets, click on your registration number. I believe every one of us are like, we've known our registration number by now. Just click on your registration number, then click either you are present for the class or absent. I'm going to close it in the next, let's say, 5 minutes.
Hello, please. How do we know our registration number?
I sent everything to the WhatsApp group. I don't know if you are. Do we have people that are not on the WhatsApp group yet?
I just joined the
Sir.
WhatsApp group few minutes before.
If you check the group description, you will see the link there where you can check for your registration number.
Sir, is the registration about the DX028, DX0 something?
Exactly. The ID.
All right, sir.
So I've sent the link to the attendance sheet or to the chat box. In the next, I will give us 5 minutes to fill. Just click on your ID number, then fill the form. Either you are present or absent. Can we access the link?
Hello, can you hear me?
I can hear you.
The link is for registration form, not the attendance form.
It's for what? The attendance form is on this chat link right now. The one on the WhatsApp
the
link
form
is for the registration number to check for your ID.
What I'm seeing here is this thing.
The what?
Is the details we filled in the. Is the details we filled
Form
during the train, doing the.
At the top, click